Hello everyone, welcome to my channel. In this video, we will learn about dependency inversion principle or known as DIP. This is the last principle of solid. If you see S solid principle, that SOLID, that D stands for this dependency inversion principle, or this is also this D is also known as, or this dependency inversion principle is also known as DIP. So every principle of solid focus on different things. So what is extra or additional thing we will learn with this DIP, or what does it tell? As of now, all other method or all other principles or first four principles told about relationship between the classes, or we can say that what are the things needs to be considered while communicating in class. But or we can say composition, it's more on compose. But this principle, it tells about loose coupling of modules. Also you will find that there are several articles known as interface based communication. Which lots of programming focus on interface based communication or protocol oriented development communication. Those are also related to this DIP, or those are taken from this DIP. So first it tells about loose coupling of methods. So means intramodule, how we can make it loose couple. What is the advantage of loose coupling? In software programming, we need to consider that everything is replaceable. If anything is replaceable easily, then it is loose coupling. And if in case something takes long effort to replace, that means it is tightly coupled. And a good software design focus on loose coupling, not tightly coupling. Let's take an example of any laptop or computer. There we get some it has some RAM, and also we can increase the RAM. Also, let's say in case of some problem in RAM, we can replace it. So if we can do that, then it is a loose coupling. But let's say in case of mobile, once we purchase, after that it's very difficult to increase the RAM size, because that is tightly coupling. So this DIP focus means helps us to achieve loose coupling of modules. It tells two things means to achieve this loose coupling. One is higher level modules should not import anything from lower level modules. Here higher level module means the above line means we can say that it's interface or abstractions. So higher level, that means it tells both should depend on abstractions. In two modules, whichever module is for communication or representative of one module, that is considered as higher level module. And similar thing for also is there in the second module. So those modules should not import anything from low level modules. That means both should depend on abstractions. For example, interfaces. Okay. See, first told that a high level module should depends upon abstractions or interfaces. Next tells that abstractions should not depend on details. Here details means concrete class or the implementation. Instead of it tells details should depend upon abstractions. So first told that high level modules should depend upon interfaces, and second told that interface should depend upon again interface. In this case, it told that how the software development or how we can make our modules loose coupling. Let's take an example. Generally, we have seen that in any e-commerce application, there is a product listing screen where on search of something or on search of we see the list of items. Okay, so we can say one we have product listing or a product module. Let's say one module we have product module, and also inside the product module we have seen that there is our banners, which tells, let's say, some different type of UI or it's a banner implementation. On click of that, it tells that or it tells 50% off, or maybe to some other page. So in that case, let's say another module we have banner. So both are different modules. If product module is a separate module and banner module is a separate module, now it tells that product module or the let's say the product module high level communicator is a class, not interface. So, and a similar thing, let's say, is there with banner, and here we are saying that let's say product module has the high level class as product.java. Similarly, banner module has banner.java, and both are depend on each other, and this is the symbol for depend. So in that case, in future, let's say we found that this banner means is not that worthy, or let's say we want new implementations for the banner, and we want to replace it with, let's say, add monetization. .java. In that case, it will be very difficult, because this class directly or this higher level module as of now which we are considering, that directly or that has lots of dependencies of banner.java, which is actual implementation. We are saying that both are actual implementation. So one actual implementation has hardcore dependency with another concrete class or the implementation class. So it's very difficult to replace it. Instead of that, what it tells that create one interface, or let's say one interface will be there. And when we are saying interface, we have this is the implementation. This is the, let's say, this is implementation class. This is the interface. So this product module, let's say it has one interface, and this is the higher level module, not this product.java. Product.java will be implementation, or it is a lower level class. So we have created one interface layer, that is higher level module of product or higher level of product module. Similarly, we will create another. In banner module also we will create one interface. Let's say we can say iBanner.java. It's an interface. Again we are saying this is an interface, no implementation. This is also interface, and let's say this is iProduct.java. So, and this banner.java, our banner.java or the lower level module, it implements the from iBanner Java or the interface implementation of this one. So in future, let's say we want to replace this banner with augmentation. So in that case, only change will happen here, no other place. We can just move this out and give another implementation. There will be no dependency of this module, or this product module will not get affected, or it will be very easy to replace. Reason is that this module depends upon this iBanner. This product module depends upon iBanner Java, or that is interface of banner module. Okay. So one interface also we can say here in even inside this implementation of, or inside this module also, we can say in interface generally we put some, means we add some methods, and then that also should depend upon interfaces or abstractions, not concrete implementations, because anything can be replaceable. Even this one also can be replaceable in future. So all the communications, or we can say the communication should happen in interface, means using interface, and all the dependency thing, means interface should depend upon interfaces, or another word we can say abstraction should depend upon abstraction. And here also abstractions doesn't depend upon the implementation or the concrete classes, rather than concrete class depends upon abstraction. Another quick example will be in let's say we have created one method, that is, let's say the method is process void, and it, let's say, parse some JSON data and validate it, let's say. In this, and also that let's take an example that it takes one array, means one list of input type is some list of object against which that JSON data will be validated, that whether the key exists or not. And array, we have mentioned array list of string is the input type, str or list. If we create a method something like this in our higher level class, then the problem is that this is tightly coupled to the array list, and array list is a class. Tomorrow, while replacing, it will be very difficult. Instead of that, it will depend upon list, not array list, where list is the interface. Similarly, when in several places we will find that we have taken hash map. Let's consider that if we use hash map in our argument, method argument, then any change from hash map to tree map, in let's say in future we found that in our case tree maps suits good, it will be very difficult. There the changes will be more. Instead of that, or we will say the calling environment should not break. For that, instead of hash map in our argument, method argument, we will say it will be map. And map is also one interface, and map have different implementations. One is hash map, one can be also tree map. So similarly, linked hash map. So based on our use case, we can change the internal logic, and this the calling environment will not change or will not break, because it depends upon the map interface and we are changing the implementation. This is one quick example from Java, and in most of places you will find in even in SonarQube tells that means use interface. If you use array list, then it will give one error. SonarQube will not error, we can say warning, so, or issues in SonarQube. So that also tells us a similar thing, that we need to use interface. And in this way we have achieved the loose coupling. There are a lot more benefits of this DIP. DIP also helps us to resolve the cyclic dependencies. And the major thing also, major thing we will say, it helps us to achieve loose coupling. Thank you.